Hello and welcome to the video on solubility. This should give you a basic introduction to solubility and some of the solubility rules that you may encounter early on in the AP chemistry course. So first you might be wondering, what is solubility? And solubility is simply the amount to which a substance can be dissolved in another substance. And so now we're going to go over some terms that you should know before you start into other solubility work. First, the solvent, and the solvent is simply the substance in which another substance is dissolved. So for example, if you were to have NaCl and you were dissolving that in water, water would be the solvent into which the NaCl is dissolved. And that brings me to the solute, and the solute is simply the substance that is being dissolved. And in this case, that would be the NaCl. Insoluble. An insoluble substance is simply something that cannot be dissolved, and that leads to the formation of a precipitate, which is simply undissolved solid solute. So now that you know some of the terms, you might be wondering, is this substance soluble? And the way that you determine solubility, it mainly revolves around the concept that like dissolves like. So for example, that just pretty much means that polar solvents dissolve polar solutes and nonpolar solvents dissolve nonpolar solutes. So for example, KOH, that's highly polar because it's an ionic bond, and we know that the water molecule is also polar, so therefore we can determine that KOH dissolves pretty easily in water. However, nonpolar solvents like alkanes, those are nonpolar, so those don't dissolve in water very well. And it's good to remember that polarity depends largely on IMFs, or intermolecular forces, and molecular geometry, so you might want to review that section before you go forward in determining whether or not something is soluble. And just remember that the concept of like dissolves like is a general guideline. There are exceptions, however, to this. For example, OH negative is generally an insoluble compound, which leads us to ions to memorize, because then these are just some simple polyatomic ions that you should encounter. You will encounter these on the AP exam. So you're just pretty much going to have to rote memorize this. However, there are some important patterns that I'd like to point out simply for this idea of dissolving stuff in water, and this is all referring to solubility with water as the solvent, just so you know. So, for example, alkali metal cations, which you'll notice on the bottom part in the insoluble compounds, the exceptions. Alkali metal cations are always soluble, and this is mainly going back to the idea that like dissolves like, because when you have an alkali metal in a compound, this will generally form an ionic bond, which is highly polar, and as we know, polar solvents dissolve polar solutes. Another thing that's always soluble is NH4 positive. That cation is always soluble. And you'll notice in the beginning that salts containing silver, lead, and mercury are generally insoluble. And those are just some kind of janky transition metals, so that's something that you should just memorize. And then also, even though it says on the bottom that OH negative is soluble with heavy alkaline earth metals, which include calcium, strontium, and barium. These are actually of hand-wavy solubility, and that's also, you'll notice that with the sulfite ion, that becomes insoluble with strontium, barium. So that's just another thing that you're going to have to memorize, and this comes up a lot, so don't save it to the end. Now that you know that whether or not something's soluble, you might be wondering, how soluble is it? And that's shown with a solubility chart, and that is displayed at the right here. So you'll notice that on the bottom, on the x-axis, that displays the temperature, and it increases to 100 degrees Celsius, or the boiling point of water. And then on the y-axis, this describes the extent to which something is soluble. And this may be given in moles per liter, or molarity, or kilograms of solute over liters solvent, or molality, or in this case, this just says the grams of the solute in the grams of the solvent. So for this, and this can also be determined experimentally. You might do a lab on this, and this just simply describes, the line on this graph describes the maximum amount of solute that can be dissolved in a solvent at a certain temperature. So, for example, how much potassium dichromate can be dissolved in 200 grams of water at 90 degrees Celsius? I'll give you some time to figure that out. Alright, you should have determined that 140 grams of potassium dichromate can be dissolved in 200 grams of water, and that's just given by, if you see on the graph, at 90 degrees Celsius, 70 grams of potassium dichromate can be dissolved in 100 grams of water, and you would simply obtain the number of 140 by multiplying that by 2, because we're using 200 grams of water and not 100 grams. And this can also be useful to determine whether or not a precipitate will form, or if a solution becomes saturated or supersaturated. For example, at 10 degrees Celsius, will a precipitate form if 50 grams of sodium nitrate is dissolved in 50 grams of water? And again, I will give you some time to figure this out. Okay, you should have determined that yes, precipitate will form because you should notice that 80 grams is the maximum amount of sodium nitrate that can be dissolved in 100 grams of water at 10 degrees Celsius. So in 50 grams of water, therefore, only 40 grams of sodium nitrate can be dissolved. So therefore, 50 grams is just simply too much, and 10 grams of sodium nitrate will precipitate. So that is the video on basic solubility. I hope that helped.
NO3 and CH3COO are soluble. Bromine, chlorine, iodine are soluble too, except with silver, mercury, and lead. Ooh, ooh, ooh. Next comes sulfur and hydroxide. Both are insoluble, with some exceptions you might like. Ammonium, barium, calcium, strontium, and alkali metal cations. Yeah, that's right. Then there's phosphate and carbonate. Also insoluble, isn't that great? Except when it comes to alkali metal cations and ammonium. What? Last we've got sulfate, and it's soluble, just not with a few of its states. Strontium, barium, mercury, and lead. Now that you've got them all down, you're all set.